All right, we're going to do question 17 from the practice final here. So for question 17, it is we got a load of 12 ohms located 800 feet from the source voltage. So I'm going to start drawing this out a little bit. And so we have our circuit here. Say this is like a motor. It's 12 ohms. And we know that it's 800 feet from the source to the motor, which means it's going to be 800 feet back as well. We know that the source is 240 volts, indicated right here. And the conductor size is number 12 copper. So the conductor size, if we cross-reference the chart that we have in the back of our practice test, if you take a look at 12 AWG and a couple columns over, it's going to give us a circular mill area which is 6,530 CMA. All right. So what the question is asking is, what is our voltage drop going to be across our load? But what we got to keep in mind is that the conductors also have some resistance. And that resistance can be found out. We can't just neglect it. Everything, even copper conductors have resistance. And we can find that resistance out by using the formula R equals K times L for CMA. Now K is going to be our resistivity of the particular material. So we're using copper, and if you remember, and you're going to need to know this for the test, the resistivity of copper is 10.4. Our length is going to be 800 feet. And the CMA, as we found out in the back of the practice funnel, is 6,530. That's going to give us a resistance of, if we put that into our calculators, 1.274 ohms. All right. So we can place that resistance at a resistor symbol there and there. So now what we're looking at is basically a series circuit. We have 240 volt source. We're going to have a voltage drop across this resistance, voltage drop across this resistance, and a voltage drop across this resistance. So what we got to do to figure out our voltage drops is to figure out what our current is flowing through this circuit. And keeping in mind that the current that flows through this circuit is going to be the same. There's no alternative paths it can take. The total current is going to be the current that is seen at each of these three resistors. So we already have our V total, 240 volts. And to find our R total, we can add all our resistors together. And that's going to give us, 14.55 ohms. Now, if we take 240 volts divided by 14.55 ohms, Ohm's law, I equals V over R, that's going to give us 16.5 amps flowing through our circuit. That means we have 16.5 amps flowing through that resistor, 16.5 amps flowing through that resistor, and most importantly, we have 16.5 amps flowing through our load resistance. Now all we got to do is, using another variation of Ohm's law, V equals IR, we can multiply our 12 times 16.5, and we get a voltage drop that's equal to 197 volts. And so our answer would be C.